Today we'll get into hypothesis testing. And hypothesis testing is, well, sort of as it sounds, right? It's a way to test a hypothesis. So to back up a second, a hypothesis is something that you think is true. You have some idea, some intuitive possibility that this might or might not be the case, and you call that a hypothesis. Then your next step is to test that hypothesis to see if it's true or not. So we'll start with just a basic introduction, the different types of hypothesis tests you can run, and then probably do another video we get into a little bit of the critical value approach for hypothesis testing. So here's my example. I put the stat grades up online for the second stat test, and you talked to a couple of people in the class, and I claim that the mean of the test is 87%. Okay? So the null hypothesis is the starting point. So I'm starting by saying the average for the whole class is 87%. Well, that would be the null hypothesis. And the notation that we use is this. H for the hypothesis, sub 0. So the mean is 87. So the null hypothesis is that the mean score is 87%. Now, you start talking to people in the class, and nobody in the class that you're talking to got an 87%. So your alternative hypothesis, which is H with a little a underneath it, that's the notation that we use for the alternative hypothesis. The alternative hypothesis is that the mean is not 87%. Now, you might be more specific. You might say, I think the mean is less than 87, or I surveyed a whole bunch of people and they all did better than 87, so I think the mean is greater than 87. So it is possible that your alternative hypothesis might be a little bit more specific. It might say that you think that the mean is greater than the given number or less than the given number. So your alternative hypothesis can be one of three things. It can be either that the mean is greater, that the mean is less, or you don't know which way it goes, so you simply say it's not equal. All right, so we have three different types of hypotheses. One is the null hypothesis. That's the one that's going to be tested. That's me saying that I say that the mean is 87%. The alternative hypothesis is the one that you come up with. That's the one that we're going to consider as an alternative to my hypothesis. And then the hypothesis test is the actual test that we perform to determine whether or not there's enough evidence for rejecting my hypothesis and going with your hypothesis. So we're going to see if there's enough evidence to reject the null hypothesis in favor of the alternative hypothesis. We really never get to the point of proving the alternative hypothesis. What we do is we look and see whether there's enough evidence to reject the null hypothesis in favor of the alternative hypothesis. All right, so a couple of terms that we might come up with. That first one, where I simply said the mean is not 87. We call that a two-tailed test, because all I'm saying is that I don't think that my mean matches your mean. But I'm not saying whether I think that it's higher or lower. I'm just saying it's not. So we call that a two-tailed test, because the area could be on either the right side or the left side of that normal curve. The second one is called a left-tailed test, because if I say that the mean is less than the sample mean, then the area is on the left side of that normal curve. And then, of course, the other version is that it's greater than. Okay, so if you think that the sample mean is less than the actual population mean, that the population mean is greater, then we call that a right-tailed test. So if it's a two-tailed test, then I'm simply saying not equal to. If it's a right-tailed or a left-tailed test, then it's going to be greater or less than, and we call those, oddly enough, one-tailed tests. All right, so let's look at this one here. 2017, average price of a used statistics book was $57.61. I want to perform a hypothesis test to figure out whether this year's mean price has changed since 2017. So, notice that I didn't say whether it's more or less, I just said that it's changed. So the null hypothesis is the one that's given to me. So the null is that the mean is equal to $57.61. If I want to find out whether that has changed, then the alternative hypothesis would simply be that the mean is not equal to $57.61. So what type of test is this? This is a two-tailed test. Because it could be that the prices have gone up because prices on textbooks always go up. Or it could be that they hit a flood of those textbooks on the market and the price actually dropped. So I don't know whether it's more or less. So because I don't know, I'm not going to hypothesize about it. I'm simply going to say I think it's not the same as it was in 2017. So not equal to. And because it's not equal to, it's a two-tailed test. It could go either way. All right, here's another example. I'm looking at the age at which people are diagnosed with dementia. I find the mean age of diagnosis is 55 years of age. They want to determine whether the mean is less than this. All right, so the null hypothesis is that the mean is equal to 55 years of age. All right, the alternative hypothesis is that the mean is actually less than, right? So the alternative hypothesis, because they want to find out if the mean is less than this. The alternative hypothesis is that the mean is less than age 55. So I might take a bunch of ages of people who are diagnosed with dementia, and from that sample, I might have enough evidence to say that the average age of diagnosis is less than 55. All right, so is it two-tailed, left-tailed, or right-tailed? It's left-tailed, because I'm working my way to the left of 55 years old. All right, so there could be errors associated with this, and I'm going to put the PowerPoint up for all of Chapter 9, and you can take a look at some of the different types of errors, but the two main types of errors that we can do is this. We can reject the null hypothesis when it really is correct, and we call that a type 1 error. Or we could accept the null hypothesis when it isn't true, and that's a type 2 error, or of course we could be correct, right? We could reject the null hypothesis when it should be rejected, or accept it when it should be accepted. The type 1 error is sort of the more fatal error in the sense that if you reject the null hypothesis, then you're done and you don't consider it anymore. Whereas if you accept the null hypothesis, there is still that chance that you could reject it if it turns out that it's not true. But if you reject the null hypothesis and you shouldn't have, then your problem's over and you don't consider it anymore. So in statistics, the type 1 error is more fatal than the type 2 error. All right, so if you go back to my textbook problem, look at the two different ways that I could look at this type of error. So suppose that this year's price really was $57.61, and I rejected it when it was actually true. That's the type 1 error. Suppose that this year's price differs from the $57.61, and I rejected it, and it really should have been rejected. That's a correct decision. So you can see between the type 1 error and a correct decision, if I rejected the null hypothesis, but it was actually true, that's a type 1 error. If I rejected the null hypothesis and it was false, then that's a correct decision. That's what I should have done. All right, the other thing that comes into play when we talk about these hypothesis tests is the significance level. How accurate do I want to be when I come up with these null hypothesis and decide whether to accept or not accept them? So how likely is it that I'm going to make a type 1 error? The probability of making that mistake is called the significance level. Now, we generally are comfortable with very small values for that significance level. The probability of an error, we want to be pretty small, right? We don't want a 40% chance of making an error. We want a very small probability of making that error. So we use small values for alpha, like at the 5% significance level or at the 1% significance level. And even though it sounds insignificant, it actually is significant, right? If the probability of an error is very small, then our results should be taken more seriously. If we're at the 1% significance level, that means the chances that we make a type 1 error is only 1%. So the probability that we don't make that error is then 99%. So the significance level being small is a good thing. It means that the probability that we make a correct decision is big. There's also a probability for type 2 errors, but we really don't cover that in Stat 1. So I'd kind of mention at the beginning of this video that we're going to be a little bit careful about how we word our conclusions. Suppose we don't reject the null hypothesis. We don't say that the null hypothesis is true. What we say is that the data doesn't provide enough evidence for the alternative hypothesis. So I'm not saying that the null hypothesis is true. I don't know that. What I'm saying is I haven't hit that threshold yet where I can reject it. So we say that the data does not provide enough evidence for the alternative hypothesis. On the other hand, if I do reject the null hypothesis, I can say the data provides enough evidence to support the alternative hypothesis. So I'm talking about a threshold of evidence, not stating that one specifically is true. I'm saying that there's not enough evidence for the alternative hypothesis, or I'm saying that the data provides sufficient evidence to support the alternative hypothesis. I can't say with 100% certitude whether one or the other is true. I'm simply looking to see whether I've met that threshold of evidence. All right, the other thing that you might see in terms of results, especially if you're looking at like a study of some sort, is the significance level. So if the test is performed at the 5% significance level or the 1% significance level, we say the results are statistically significant at that particular level, okay? Or not statistically significant at that level. So depending on whether we accept or reject the null hypothesis, if the null hypothesis is not rejected, then we say the test results are not statistically significant at that level. And that lets people who are reading, for example, a scientific study or even a poll or research study tell you how far they went in being accurate. Did they go to the 10% level, the 5% level, or did they drill all the way down to the 1% significance level? All right, so let's take a look at this problem here. This is a study that's monitoring fatigue in a steel plant. Okay, looking at heart rate samples of 29 workers. I want to determine if the mean post-work heart rate of the workers exceeds the normal resting heart rate of 72 beats per minute. So my null hypothesis is that the mean is equal to 72. Okay, so without any other evidence, you would assume that their heart rate is the same as everybody else's heart rate. All right, determine the alternative hypothesis. So I go back to my question. Determine if the mean post-work heart rate of workers exceeds the normal resting rate of 72 beats per minute. So my alternative hypothesis, my HA, is that the mean is more than 72, okay, exceeds the normal resting heart rate. So what is this? Two-tailed, left-tailed, or right-tailed? It's right-tailed because I'm looking at values that are above 72. So what would a type 1 error mean? Type 1 error means you reject the null hypothesis, but you shouldn't have. Okay, a type 2 error then would mean that the sampling showed that the mean was actually equal to 72, and you didn't reject the null hypothesis. What would a correct decision look like? Well, a correct decision would be that either the mean is equal to 72 and you didn't reject the null, right? So you have actually two possible correct decisions. One of them is that the mean is actually equal to 72 and you don't reject the null hypothesis. Or the other possibility is that you conduct the test and find the mean is actually greater than 72 and you do reject the null. All right, so that's what a correct decision looks like. All right, and then the last question there, last two questions say, suppose the testing is done, the null hypothesis is rejected. Okay, classify it by error type or correct decision. So suppose that the heart rate exceeds the resting rate of 72 beats per minute. And we rejected the null hypothesis. So we rejected the null hypothesis when the mean was actually equal to 72. So that's a type 1 error. We rejected it, but we shouldn't have rejected it because the mean was actually equal to 72. All right, this second one says what happens if the mean exceeds the resting rate of 72 beats per minute and we rejected the null. Well, then that's a correct decision. All right, we ran our test. We found out that the mean was actually more than 72, so we reject the null hypothesis in favor of the alternative hypothesis. All right, that's the end of 9.1.